Hello there, you are welcome. I am Uncle Agbaje. This video series I am doing based on the Unified Lesson Plans of the Lagos State Universal Basic Education Board LASUBEB for mathematics teachers who may have challenges with understanding some of the topics that they are supposed to teach. This week we have been learning about estimation and approximation. Today we're going to be looking at a subset of that, which is rounding off to significant figures. What are significant figures? Well, join me as we go into it. Welcome to approximating to significant figures. To start with, what are significant figures? Why do we approximate to them? Approximating to significant figures is something that many students stumble on whenever they get to that bridge. Teachers make mistakes when they come to that bridge. So, what are significant figures really? To start with, every non-zero digit is significant. That means that numbers like 1, 2, 3, all the way to 9 are all significant digits. 0 itself is not a significant digit by default. However, 0 becomes significant when it is in between significant digits. For example, in this case of 200 as a number, we have 2, 0, and 0. The only significant digit there is 2, so this one has one significant figure. Here we have 2005. These zeros are significant because they are in between two significant digits. So here we have 4 significant figures. Here we have 0.0045. The 3 zeros that are at the beginning are not significant because they are not in between two significant figures. So the only significant figures here are 4 and 5. We have 2 significant figures. However, in this case, 0.00305 or 0.0305, this 0 and this 0 are not significant because they are not in between two significant figures. However, this other 0 is significant because it is between 3 and 5. So altogether, the significant digits are 3, 0, and 5. So there are 3 significant figures in there. I hope this clears your mind as to what significant figures are. 0 is the only digit that is not significant, but it becomes significant when it is between two non-zero digits. Let's move on. Let us consider 46,235. Here, this number has the largest value, so it is the most significant digit. The value is 40,000. This is the next most significant digit, 6,000. This is the next most significant digit, 200. This is the next most significant digit, 30. This is the next most significant digit, 5. So, the values determine their significance. So when you are asked to round off a number to 3 significant figures, that means you will pick the 3 most significant digits. When you are asked to round off to 1 significant figure, then you pick the most significant digit. Let's now look. This question says, round off 768,389 to 2 significant figures. In this case, we will pick the 2 most significant digits, and these are 7 and 6. What that means is that we're actually rounding off to this place value, the place value of 6, which is 10,000. So, the general rules of approximation now applies. We have 76, and then every other digit becomes 0. That's 760,000. And then counting in 10,000s, the upper bound will be 770,000. Of course, in between, we'll have 765,000 as the mid value. Now, 768,000 falls after that, in between 765,000 and 770,000. So, the upper bound will be the number that we are rounding off to. So we say 768,389 is approximately 770,000 to 2 significant figures. In your final answer, you must have only 2 significant figures. And as you can see, we have 2 significant figures in the answer, 7 and 7. These other zeros must be there because if they are not there, the value of that 7 now goes away from 770,000 and becomes just 77. So we must put D. So we must put the last set of zeros in this case. This question says round off 0.0475 to one significant figure. In this case, the most significant figure there is not 0, it is this 4. So to use that to form the lower bound, we just change all the other zeros out, all the other digits after its zeros. So we have 400 as the lower bound and 500 as the upper bound. And then we can find the middle value, which is 450. 475 comes somewhere here after the middle value. So the closest 100 is 500. So in the original number, we will replace 475 with 500. So we can now have 0.0475 is approximately equal to 0.0500. 0.0500 to one significant figure. But we do not need these trailing zeros because zeros after decimal points are not important. So we'll just say 0.0475 is approximately equal to 0.05. And you can see that we have just one significant figure here. So one significant figure. It's as simple as that. This question says round off 5.3046 to three significant figures. The first significant figure here is 5. The next significant figure is 3. The next significant figure is 0. This 0 is significant because it is between two significant digits. And that means we are rounding to the 100th position. Let's just form our lower bound from here. We have 5.30. That's the 100th. So all the other digits become 0, 0, 0. And then to the upper bound, we have 5.3. The 0 in the 100th place becomes 1. We have 0, 0. Now to the middle value, we're going to have 5.305. Okay. Now 3046 is going to be before 3050. So 5.3046 is here. And that means it rounds back to 5.30. So in the original number, we're going to now replace 5.3046 is approximated to 5.3000. But we need three significant figures, so we have 1, 2, and 3. We'll cancel these two zeros. So we must have 5.30. Remember that we said that this 0 is a significant digit, and when the question says you should round off to three significant digits, you don't cancel that last 0 in this case. So the three significant figures, the answer is 5.30. Let's look at another problem. This question says 4.25, you should evaluate 4.25 times 2.5 to two significant figures. So the first step to do is to calculate the actual solution. It's 4.25 times 2.5, and when you multiply that, you get 10.625. Now that we've gotten the answer to that, we now need to leave our answer in the two significant figures. So the first significant figure is 1, the second significant figure is 0. So which means that we're rounding to the nearest unit. So we can now form the next unit. This number now is between 10.000 and 11.000. The middle number, of course, is 10.500. 10.625 is after 10.500, so that is falling to the right. And that means it is closer to 11.000. So we'll say 10.625 is approximately equal to 11.000. But since we are told to leave it to two significant figures, you can conveniently remove all the trailing zeros to say it's approximately equal to 11 and write two significant figures. Alright then, that has been it on significant figures. Remember, significant figures are numbers that are non-zeros. 0 becomes a significant figure if it is between two significant digits. Significant figures, to round off to them is similar to rounding off to place values. when you count the number of significant figures that you want, the place value you end up with is a place value you want to round off to. That has been it for this lesson and indeed for this week on estimation and approximation. If you would like to see how the quantitative reasoning question is solved, then you probably want to check out the next video. I'll see you then. Bye right now.